In this video, we're going to cover a problem involving a photo or a picture being enlarged to a larger size. So we want to take a photo, so this picture of the apple, and we want to print it at a larger size. So it says here, Amelia has a photo of an apple and a rectangular piece of card. So here's the photo of the apple. Here's a rectangular piece of card. She cuts the card along the dotted line as shown, so this dotted line, to make a backing for the photo. She throws away the piece of card that is 25.5 centimeters by X. So she's going to discard this bit of card. The piece of card she has left is mathematically similar to the photo. So the piece of card left, which is this, so this is the bit of card that's left, that is mathematically similar, I'll explain what I mean by that in a second, to the original photo. Yep. And the reason that's important is that you might want to, for example, print this photo larger to this kind of size here, the purple size here. But the thing is, if you print it larger, this has to be in the same sort of aspect ratio, the same proportions as this purple one. So you're going to have a bit of wastage on the side here. So mathematically similar, that just means that the two shapes, if they're similar, it means they're the same shape, but potentially different sizes. And the important thing here is that all the lengths scale in the same way. So for example, if you double the width, you also got to double the height. If you triple the width, you also got to triple the height. So let's draw these shapes separately. We've got the picture of the apple in yellow, and we've got the bit of the card that's left, which is here, and they're mathematically similar. So whatever we scale each of the lengths by is got to be the same. Now let's just draw the lengths on here. For the apple, we've got 17 and 23. And for the purple one, well, we know that the height here, that height here is 25.5. So that's 25.5 here. And we don't know this width here. So that's a mystery. We need to work it out. Now, we said all the lengths have to scale in the same way. So this height here of 17 is scaling by some scale factor to get the height of the bigger rectangle. So if we just divide those, we do the second number divided by the first. So we do 25.5 divided by 17, which I believe is 1.5. So that scale factor is 1.5. That means that this length here has to scale in the same way. So we also need to times it by the same scale factor of 1.5. So we just do 23 times by 1.5. And that gives you 34.5. So this bottom length here, therefore, is 34.5. So if this is 34.5 here, we said of the original piece of card, before we trimmed a bit off, that whole width here was 39. So therefore, we just need to do the 39 minus the 34.5 to get x. So x is the 39 minus the 34.5, and that is just equal to 4.5 centimeters. And that is the final answer.